Hi, today I'm going to talk about an Internet of Things IoT use case demo. In this case, I'm going to be looking at a demonstration that optimizes resource usage. My name is Martin Madsen. I have a PhD in experimental physics and about 15 years of experience working with sensors, data collection, data analysis, and predictive model building. Just to start off with the definition of IoT, it consists essentially of 5 pieces. First of all are the things themselves, the actual physical devices, whether it be a camera feed, machine recordings from machine positions or positions of vehicles or people or interactions between people and the machines around them. Those machines become connected to the cloud through some kind of connectivity, whether it be Wi-Fi or some kind of local connectivity, and then some kind of gateway router that connects them to the network as a whole. The data that comes from the machines, and in most cases we're talking about large quantities of data, which make it challenging for humans to analyze by themselves, so there comes some kind of analytics, some kind of machine learning or other computer analytics. And then the last piece in a typical IoT deployment is the actions themselves, some kind of change in the way a business interacts with its customers or in the way that the business sees its own models. So there are instances and cases of IoT projects that change the business model completely. There are a number of different types of IoT projects that enterprises are deploying, and these come from a Vodafone barometer that was published in 2016. And today I'm going to particularly be talking about optimizing fleet and asset utilization. And this is just one particular way in which an IoT project can help improve the efficiency that a business sees and experiences as they're working with their assets. Here's the scenario. We're looking at things that are deployed in the real world, and they could be at power plants or vending machines. And I want to look at a case where they have a choice of resources to utilize. And so an aircraft this could be a choice of paths to take, or it could be for an engines, it could be a choice of settings to run on. And the device itself doesn't know which option that is best. What's the most efficient way to utilize those resources in order to optimize the outcome? So what the device is going to do then is going to send the options to the IoT hub for evaluation. The hub is then going to use the things that it's learned from previous experience and other devices to then choose which of those options are going to be best using some kind of machine learning algorithm. The hub will then return the best choice to the device, and then the device will use the resource. In order to improve the algorithm, the device will then return the outcome of the utilization of that resource, which could be flight time or profits on a particular device, and send that back to the IoT hub so that the hub can then improve the machine learning algorithms and improve the overall efficiency of the system. In this demo, we're going to replace a thing with a movie studio, and we'll use the Amazon Web Services, AWS's IoT hub, as the network connection point for deploying the choices and for doing the machine learning piece of the demo today. The movie studio is going to have a set of choices to make in terms of deciding whether or not to make a particular movie or which movie to make. And I've narrowed it down to 3 choices. The movie studio could choose a director. So who's going to lead the project? It could choose a year in which to make the movie, which is not totally realistic, but movies have changed over time, and so some movies that might have been made in the past might not be as popular now. And the movie studio can choose the genre, and the typical movies have a couple of different genres that the movie could be classified into. And then the result is going to be the viewer rating. How well was the movie received by the viewers? And certainly higher stars mean a better movie. The historical data that I'm using to train the initial model for this demonstration comes from the Internet Movie Database, and it was accessed via the IMDb API. I have data for about 16,000 different movies, and you can see over time the number of movies made per year has certainly increased dramatically since the 1920s and 1930s. That's leveled off more in the last 10 years or so, but I have about 16,000 films to work with. The average rating on those films over time averages about 6 to 7 stars on the IMDb ratings. I only looked at films that had more than 1,500 user ratings, so we're not looking at films with just 1 or 2 ratings on them. These are films that enough people have seen that the average rating is a fairly decent representation. Over time, the ratings have stayed fairly constant, with perhaps a little bit of dip in the last 25 or 30 years. There's certainly more movies that are being made. There's a higher chance that the movies aren't as good. So you can see the dip is slow, and it has been pretty consistent for the last maybe 20 years. I take a quick look at the different genres and how those have the number of movies and the ratings of the genres over time. So that what we're looking at here is the normalized rating. This is rating of the genre compared to the overall rating of all movies. And so some genres like the documentary increased in the ratings. The viewers liked those movies better in the 1980s than compared to now. The animation genre has been fairly consistent. Perhaps the action genre has decreased a little bit in popularity over the last maybe 50 or 60 years. In terms of the number of all films being made, the number of action films being made as a fraction of total film has certainly increased over the last few years. The animations has been fairly consistent, with a dip in the 60s and 70s and then a resurgence now. Documentary film certainly has increased the number of documentaries. War movies, however, have dropped dramatically. The big push to make war movies in the 40s and 50s, and not so much now. I also look at the directors' ratings. So this is the average director rating for all the films that the directors have made, and I only looked at directors that had at least 2 films on the IMDb. And so the number of films that they make versus their rating, there is a little bit of correlation here, although directors tend to be pushing towards the mean with the more films that they make. I dig a little bit deeper for directors that have 20 or more films, because there are only a handful of those directors. And looking at the number of films that these directors made, that's topped by Woody Allen, followed by Alfred Hitchcock, Clint Eastwood, John Ford, and then so on down the list. Perhaps more interesting is not the number of films that these directors have made, but the ratings of those films. And that reorganizes the list significantly, where now the list is headed by William Wyler and Martin Scorsese and Charlie Chaplin. And so these are the most popular directors, but those directors were actually placed in their time. So it's hard to say whether or not some of these directors would be more popular before or after the time in which they actually directed their films. So in order to train the model, what I did was take this data from the IMDb and uploaded it into an AWS S3 storage container. From there, I can pull it into the machine learning and do some training on the data. I used a decision tree, a boosted decision tree algorithm for training this, and it turns out that there's just not enough data to really be a really good model. I'm okay at predicting 5, 6, 7, 8 as the movie ratings, sort of the bulk of the movies, but beyond that, it essentially defaults to predicting a 6 for every other movie. In fact, there's no predicted values for anything outside of that range. So even though it's not a very good model, at least it's a baseline, and certainly in a real-world situation, as we got more data from the IoT devices, the model would improve. So deploying this scenario is going to start with the choices, and I implemented a small script on a Raspberry Pi as my device that pulls out a random collection of directors. And so just to step through one example, I pull out a choice of 3 different directors. And in this case, they were Alfred Hitchcock, Barry Levinson, and Spike Lee, and these are just example movies that each of these directors had produced, had directed, and the years in which the directors made these films. And then I combined that with a choice of 3 different years. What year would we make this hypothetical film? And then 4 different sets of genre choices that are randomly chosen from all the possible genres. So this leads to a total of 36 different combinations of possible movies that we could make. So we could imagine, what if Spike Lee made a comedy short in 1914? How well would that film be received? So the device then requests a prediction from the Amazon Web Service IoT Hub, and it sends that request via the MQTT protocol. The IoT Hub then triggers a Lambda script, and that Lambda script then sends the request to the machine learning endpoint. The machine learning endpoint then retrieves the prediction for each of the films and returns those predictions back via Lambda script, which then returns the information back to the IoT Hub and sends the message back to the device. And this is an example of a screen capture of the device as it's receiving replies. from the IoT hub. And so each one of these is a set of the predicted labels and their probabilities, along with the unique identifier, which is a random title for each one of these possible movies. So once the device has got the predictions, it makes a decision, which in this case is a weighted probability based on the predicted outcomes, but it is a random choice. So the end result is that this data doesn't improve learning because I'm just randomly choosing the outcome. But I'm going to send the outcome back into the service. In this particular case, that combination of movies, this is the heat map showing the different options and how well the machine learning algorithm rated them. The lowest predicted score was the Barry Levinson producing a war comedy in 1997, and the highest one turns out to be a Barry Levinson comedy short that it predicts as being the best received film. So this was the final score it predicted would be a 7 out of 10, and my random number generator weighted based on the predicted scores picked a 7, and so it produced a final score of 7 out of 10 stars for the Barry Levinson comedy short, with the random title chosen from all movie titles called Wreck Boys 1991. Which makes sense given the Barry Levinson's past and his placement in history. This would fit in reasonably well to the other body of work at that period of time. So now the device sends the outcome again to the IoT hub, and then it triggers a different Lambda script because I'm using a different endpoint, and from there it stores the outcome both on a DynamoDB for long-term storage and analysis, and I also store it back on the S3 in the S3 container. I append it to the list of films that we have. That way I can use that S3 container to retrain the machine learning algorithm. And there's a simple a Lambda script that will retrain the machine learning algorithm and update the knowledge of the computer based on the movies that have happened. I'd also show a quick piece of the demo on how to monitor performance of the demonstration as it's working. From the DynamoDB, I can export the data into a Tableau to show the metrics and graphics of the data. In this case, I'm just looking at director performance over time, and I've listed out the 20 directors, the 20 top directors over the last 70 or so years. How are they performing? And in real time, I can watch as the device plays data and gets more data points. How do these averages adjust up and down as the films come in? And I can keep an eye on the metrics of the system as it's playing out. So in summary, this is an IoT demo. This was an IoT demo where I'm looking at how to optimize the use of particular resources in the devices themselves, where the things don't know how to best utilize what they've got, but we can use a combination of the IoT infrastructure to send that data to the hub for learning, and then use the learning algorithms itself to improve the predictions, improve the resource utilization from the things themselves. Thank you for listening, and if you have questions or further conversation, feel free to get in touch with me via my LinkedIn profile.